So this is the one of the problem from queuing model or the waiting line model. Let's see its solution. Now, what is the problem has been given? At post office window, customers arrive at the rate of 6 per 30 minute. That means arrival rate is given as 6 per 30 minute. So arrival rate is given 6 per 30 minutes. Means 6 customers are coming at post office window in a 30 minutes, and service time is per customer is 3 minutes. Means to serve one customer 3 minutes are required. To serve one customer 3 minutes are required. Okay. So let's see. As per our usual practice, whenever problem of queuing model, we required only two basic parameters. That is the first one is arrival rate. We required arrival rate given by lambda, and second parameter we required is service rate which can be written as mu. Okay, so let's see what it has been given first. Okay, arrival at the rate of 6 per 30 minutes. Okay, so arrival rate is given as 6 customers in 30 minutes. Okay, this is the lambda. 6 customers in a 30 minutes, so it can be written as 1 by 5 customers per minute. 1 by 5 customers per minute. 1 by 5 customers per minute. We can copy that here. So lambda is 1 by 5 customers per minute. We can convert it into hour also, just by multiplying with 60. Okay, so 1 by 5 customers per minute. Okay, second, service rate what is saying, service time per customer is 3 minutes. Okay, so service time or service rate is one customer in 3 minutes. One customer in 3 minutes. That means one customer 1 by 3 customers per minute. That means 1 by 3 customers per minute. Okay, simply 1 by 3 customers per minute. Okay, here we will keep as it is, because what happens when we will convert 1 by 3 into 0.33, it is not actually actual conversion. Okay, because 1 by 33 is a unending type. 0.333 it comes continuously. Okay, so 1 by 3 customers per minute. This is the service rate. Okay, so we have got the arrival rate, we have got the service rate. Okay, so only these two parameters are required, through which we can easily get remaining all the parameters that has been asked. Okay, so lambda we have got and mu we have got. Okay, so the first thing that has been asked is probability that newly arrived customer will get service immediately. That means he has not to wait. Okay, probability of getting service immediately. Okay, probability of getting service immediately. Okay, so first of all, understand this thing is that, see, this is the arrival rate, this is the service rate. Okay, so to get the busyness of the service center, that is called as the traffic intensity. Okay, which we are denominating by mu, sorry, rho. So it is nothing but lambda by mu. So once we will get this value of rho, it means that for that much percentage of time the server is busy, the service station is busy. Okay, and when service station is busy, there is no probability. That means for that much percentage there is no probability to get service immediately. And what has been asked? Probability of getting service immediately. It means there should not be any customer at the counter, there should not be any customer at the service station. To get that, we have to reduce this traffic density. Okay, so the value of lambda is given as 1 by 5, value of mu is given as 1 by 3. Okay, so it is simply 3 by 5. Okay, so this is a traffic intensity. This is a traffic intensity. Okay, so we want it in a percentage. So this lambda can be written as 3 by 5 multiplied by 100. Okay, so it is a 0.6 into 100. So this will be a 60%. That means for it is a 60% probability that server is busy. This value of rho is saying that percentage for which server is busy. So customer has to wait. Customer has to wait. But we want to calculate the probability that customer has should not be required wait. He should not wait. He should not wait. So if we know the probability of wait, then to get the probability not to wait, just reduce that. Okay. So we know the probability of waiting, that is 60%. To get the service immediately means we should not have to wait. So if 60% is a busyness, 40% is the probability that this server is empty. So this can be written as probability of getting service immediately is 1 minus rho. 1 minus rho. Or sometimes it can be written as 100 minus rho also. See, this is nothing but the 0.60 or zero point 0.6. Okay. So 1 minus 0.6 equal to 0.4 or 40%. 40% means there are 40% chances of getting newly customer immediate service. If you want the immediate service, there are 40% chances. Okay, and 60% chances are that server is busy. 40% chances are that service will get immediately. That means server is empty. Server is empty. Second question. The second question has been asked that average number of customers in a system, and third one is average number of customers in a queue. So before getting the average number of customers in a system, we need, before getting the average number of customers in a queue, we have to calculate average number of customers in a system. Then easily we can get in a queue. Okay, so let's calculate first. So it has been asked average number of customers in system. Okay, so it is nothing but ls, and the formula is lambda by mu minus lambda. Okay, so just we'll have to put the values, we'll get the everything. Okay, so value of lambda is 1 by 5 divided by value of mu is 1 by 3 minus 1 by 5. So it will become out as 1 by 5 divided by 2 by 15. Okay, this 5 will go here, this 3 will go here, and multiplication of the denominator. Okay, so once we will make this, it will be 15 divided by 10. Okay, so around 1.5 customers, 1.5 customers, approximately equal to 2 customers. 2 customers. So 2 or 1.5 is the answer. Okay. Now the third one. Third one is average number of customer in queue. Okay, in queue. So this is LQ. So LQ equal to LS minus those who are at the service station or the ticket counter. It is nothing but lambda by mu. Lambda by mu. Okay. So value of rho. Value of rho. Okay. So equal to, okay, let's make the calculation here. We want ls minus lambda by mu. Okay, value of ls, what is the value of ls? Value of ls we have calculated as actual value. Will take actual value, that is a 1.5. 1.5. Okay, 1.5 is the actual value of ls minus lambda by mu. Okay, So lambda by mu value already we have calculated. This is rho. Remember, nothing but the rho, that is a 0.6. 0.6. Okay, so it will come out as 0.9. 0.9. Okay, and approximately equal to 1. Approximately equal to 1. Okay, so this is a one customer. So answer is 1.5 minus 0.6 is 0.9 customer, or approximately one customer. Okay, so answer is approximately one customer. Here answer is approximately two customers. Okay, so answers are probability of getting service immediately 40%, and if I will say probability of not getting service immediately, see, similar kind of question if I want to ask in a different way, probability of not getting service, okay, that is nothing but rho, and it is 0.6 or 60%. Not getting service 60%, getting service 40%. Not getting service can be easily calculated by lambda by mu, lambda by mu. Okay, and 1 minus this will be getting service. Okay, so answer is 0.40 for getting service, two customers in a system, one customer in a queue. Okay, so these are the things. Okay, so once again I will repeat that only we want two values, arrival rate and service rate. That is sufficient to get the all the answers. Okay, it may be asked in any sense. Okay, thank you.
Hopefully you might have enjoyed the lecture. Then please do like the video and know your thoughts in comments. Please do share this video among your friends and don't forget to subscribe to our channel. After subscription you can press the bell icon to never miss the notification regarding our new videos. Thank you so much.